Hey everyone, and we are back with another project that is iris flower classification using three machine learning algorithms. And this project is especially for beginners, but like we are using three machine learning algorithms. That is, first one is decision tree, second one is KNN, that is k nearest neighbor, and the third one is clustering. Yes, that is unsupervised learning. I'm gonna explain what is the types of machine learning, that is the supervised and unsupervised. In supervised we have classification and regression. As this is a classification problem, like see, you need to classify between these three flowers. Okay, like this iris flower, but there are basically three different iris flowers, and you just cannot just see with your eyes and tell, okay, this is versicolor, this is setosa, and this is virginica. You actually need to scale their feature. You need to actually know their petal length and petal width, their sepal length and sepal width to differentiate between them. Okay, and the third algorithm which I'm going to use is clustering, that is unsupervised learning, and I'm going to explain you in a few minutes what is supervised learning and what is unsupervised learning. So let me first tell you like what is this flower actually. Okay, this is iris flower, and they look very similar to each other. Okay, you cannot just see and tell the difference between these three. So how we actually tell the difference between these three is like this: by their petal length and petal width, by their sepal length and sepal width. And that's how we can differentiate between setosa iris, iris versicolor and iris virginica. We have the data set here, our CSV file, and yeah, I've already opened. So you can see we have the data set of like 50 samples of each species. Okay, like we have sepal length, sepal width, petal length, petal width, and we have their numerical data, and we have like in target we have species. Okay, so we have 50, we have data of each species. We have 50 samples. Okay, so 50 for iris setosa, 50 for iris versicolor, and 50 for iris virginica. So today we're gonna classify between these three flowers. And now let's see what is, like, in just 1 to 2 minutes I'm gonna explain what is the types of machine learning. Okay, just like 1 to 2 minutes only I just need. Okay, this one is good. Okay, all right, and I need only this one. Okay, thanks to their respective websites. No thanks, just give me 1 minute. Damn it. Okay, so the types of machine learning for beginners I'm going to explain you like in just a few minutes, and then we're going to start the project. Supervised and unsupervised reinforcement. Okay, so now we're going to use three algorithms: decision tree, and we're going to use KNN for classification also, and we're going to use unsupervised learning's k-means. Okay, and this reinforcement learning is mostly used for robotics. Okay, so leave that. So regression is like we have in supervised learning, we have basically two types: classification and regression. Okay, and these two, decision tree and random forest, are used for both purpose. Okay, these are used for both purpose. So we have like classification is used to classify between 2, 3, 4, 5, like, okay, 5 objects or whatever, any n number of objects. Okay, And regression is we use for numerical data. Numerical data means price of Bitcoin, price of stock market or stock price, okay. And we like for price, you got it now. And in classification we have algorithms like k nearest neighbor. I am going to explain you decision trees, okay. Again, see, I don't know why they have made like this to confuse, but alright, we are not going to use other three, okay. And now let's come to unsupervised learning. How many add they have ran? And let me just okay, now let's come to unsupervised. Unsupervised, we don't use any label to train our model, okay. Like in supervised learning now we use label to train our model. Label means this this one, iris setosa, iris virginica, iris versicolor. Wait, here in classification or regression means in supervised learning we treat like we are a supervisor, you can say, okay. We give our model to train, okay, and what we give the labels, we give labels to our model to train, okay. We like these are the labels, iris setosa, iris versicolor and iris virginica is our labels. But in unsupervised learning we don't have any labels, okay. Like what happens in unsupervised learning is it differentiate it just differentiate between two things by recognizing its patterns. There might be where we go. I think we don't need to, okay. Just see this, okay. Like we just have raw data without labels, okay. Without labels, they might be anything, but okay. And then by applying clustering method, of course, means unsupervised means clustering, okay. We cluster them according to their patterns, okay. So here you can see black, I don't know what they are, but I think they are some kind of files, okay. So black files is now separated, orange files is now separated, red files is now separated, blue files is now separated, and yellow files is now separated. And how they got clustered, okay, how they got separated by their patterns. And what is their pattern? Colors, black color, orange color, red color, blue color, yellow color. So that's how they got separated now, okay. And that is what unsupervised learning means, okay. To cluster the data, okay, according to their patterns. That's all. So now what we understood is what is supervised learning, okay. We are a supervisor, you can say, and there are two types basically. So in supervised learning, classification and regression, okay. And for regression we use like for price thing, or for numerical data, population growth prediction, marketing prediction, weather forecasting type of thing, we use regression. And for classification we use image classification, customer retention, okay, and we use object classification for this kind of thing. And for unsupervised learning we have clustering, and we have dimensionality reduction, okay. Leave it for like some other class. We're gonna cluster this species of flowers according to their patterns. And what is their patterns is their features. And what is features there? Sepal length, sepal width, petal length, petal width, okay. So now I just told you the three algorithms I'm going to use. And before that, let me just tell you from where I adopted this project is this. I'm gonna give you link of this this project in Kaggle. The only difference I made was but I cannot see who made this project, sorry, I forgot the name. All right, The only difference I did was I used Plotly instead of SNS and Matplotlib. I used Matplotlib but in only 1 to 2 places only, okay, but most of the time I have used Plotly. And second difference I made was I added clustering here, okay, clustering algorithm, and this person has done it using gradient boosting. No, he has also added clustering. I'm so sorry about that, but alright. He has done using deep learning also. He has done using SVM also, okay, and he has done using I don't know, done using clustering, logistic regression also, okay, and k nearest neighbor also. But as I wanted to make a tutorial especially for beginners, so I did it using 3 algorithms so that you can actually understand the like all the logics and all the pre-processing, how we do it, okay. So if you want from SNS and Matplotlib and with all the algorithms, you can take a project from this. I'm gonna leave the GitHub link of both of our project of JVDP and mine one also, if you want to use it with Plotly, okay. He has used Matplotlib and SNS, and I've used Plotly, okay. So all right, and let's move forward to see what I'm going to actually teach you, okay. First we just gonna import the data, and then we gonna visualize, okay. We just gonna visualize like, okay, this is how we do data analysis, and this is the beauty of Plotly, okay. That's why I have kept separated. I've used Matplotlib just to show the difference between Matplotlib and Plotly, okay. Here we go, Plotly Express and all, okay. Here we go, and at last I've used scatter matrix, and I've explained everything. As I always say, I'm gonna explain every line of code. And then we come down to, first we gonna import our data, okay, and then the second step we're gonna do is visualize our data, and the third step we're gonna do is pre-processing, okay. Simple. Like I'm gonna use label encoding. I'm gonna explain you what this is. I'm gonna explain you what is one hot encoding, like I'm gonna show you what it does, but we are not gonna use it in any algorithm, but just to show you what this is, I'm gonna run it, okay. But we are not gonna use in any algorithm, so not gonna store it in while. And this is what we are doing, pre-processing, and then we're gonna split our data set into training and testing. I'm gonna explain you, and I'm gonna explain you what is standard scalar, and I'm gonna explain you everything about it, and I'm not gonna use it in decision tree. So I'm not gonna explain you in decision tree, but I'm gonna explain you in KNN when I'm gonna use it in KNN. And then I'm gonna explain you my first algorithm, like what is decision tree. I'm gonna explain you, and then I'm gonna show you, how to train. And before making the prediction, like it is making the prediction in test data here, X test, but before making it prediction into our manual data, okay. Like if you just pick a flower, and if you scale its feature, okay, and if you give that feature to predict, like even if you give 1 1 1 1, okay, to 1 means here what is in this format now, sepal length, sepal width, petal and petal width, okay. So even if you give your custom input to predict, okay, which species does it belongs, so I'm gonna explain you how to do it. But before that, I'm gonna try to explain you the visualization of decision tree, okay. Like how does decision tree is predicting our data, and I'm gonna explain you how to draw this, and I'm gonna actually explain you like decision tree is mostly based on true or false, no? Okay, like the basic part is true and false. So I'm going to explain you how to draw this, and now I'm going to explain you what does it is doing. I'm going to explain you how to visualize the decision tree at all. Okay, and then I'm going to explain you my second algorithm, that is k nearest neighbor. Okay, just training and testing again, and then sorry for all the space but then the clustering using k-means. Here I'm going to explain you how to do it. Okay, and I'm gonna use matplotlib and scatterplot also. So alright, visualization after fitting, I tried. Alright, I'm gonna leave it. So here we go. That's all we need to do. That's all. Okay, so that's all we need to do. We're gonna use 3 algorithms, and I really believe that every beginner who just don't know the basic of Python, just basic of Python, can understand this project very easily, because I'm gonna explain every single line of code. Okay, so let's start making our project. Okay, let's start. So let's start now, and I'm gonna explain every line of code, as I said, and I always say. So even if you are a beginner, feel free to watch the whole tutorial, because you will understand almost everything. Okay, pandas is for playing with data and all. Okay, we're gonna import our data file, that means the data set. We're gonna do some random stuff. NumPy is for computational task, of course, and to create the arrays and all. Plotly is our that visualization tool through which we're gonna create the visualization graphs. Okay, and I'm gonna use matplotlib also. So Plotly and Plotly Express, let me tell you, Plotly Express is the wrapper of Plotly. If you want to make graphs in Plotly, better use Plotly Express, because syntax is very simple. Plotly Express is just a wrapper of Plotly, you can say. Okay, things are a little easy on that. SPX import. We are not going to use Plotly graph objects, because visualization gonna be very simple, and I'm just gonna keep it short. Okay, so import Plotly offline. To use Plotly, as we are not using it in its dashboard as online, we are using it in Jupyter Notebook, so that's why. Sorry, PYO. Now import cufflinks. Cufflinks is a tool which we use to bind pandas and Plotly together, so that we can use Plotly in pandas. Simple. Now from Plotly.offline, import some more thing, download, and what is I don't think we need this. Sorry, we don't need this. If you are hearing a buzzing sound, it's from my laptop. Okay, yeah, it's from my laptop. Notebook mode. If you press tab in Jupyter Notebook, it will automatically complete its sentence. And I plot. Okay, plot and I plot. I plot is for Plotly, and plot means like in matplotlib plt dot thing. Okay, now we're gonna import matplotlib, our second visualization tool, which gonna use pyplot as plt. Now we're gonna import not much. One more thing, one last, to use matplotlib Jupyter Notebook. Actually, it has some uses. Inline And all right, now just press shift plus enter, and it's running, and it's importing everything, and it has imported no module and matplot. Oh, it's matplotlib, I'm so sorry. Okay, yeah, now all right, now we need to give two more commands here to use plotly. Pyo dot init notebook mode connected is equals to true, and cufflinks dot go offline. Yeah, here we go. Okay, as I said, cufflinks is used we use for to bind pandas and plotly together, and here in through this line we just connected plotly with Jupyter, as we want to use plotly in offline mode. Okay. Okay, now let's load the dataset. I'll give you the link in the description to load it. I know many of you might be thinking that we just can load the iris dataset from sklearn, but even for beginner, I just want to tell how to load this Excel file or CSV, whatever you have, in the Jupyter or in any editor, and how you can actually play with it. Okay, so it is already open. So we have three species of iris, as I've already showed you, Okay, we have 50-50 for each. Like if sepal length is 5.1, sepal width is 3.5, petal length is 1.4, petal width is 0.2, then it belongs to setosa. And things change for versicolor. Okay, the number goes little bit higher, like as you can see. For petal width, for iris setosa, it is mainly 0.2, 0.4. Okay, but for versicolor it goes higher, 1.4, 1. Okay, means above 1. And for virginica, it sometimes even go above 2. Okay, so that's how you can just see how things are changing here. So let's import the data. I'm gonna name it iris, that is data frame over pd dot read. It is a CSV file. So CSV, if it is Excel file, so I would have write read Excel. Let me I have given the path R because Python takes forward slash. Okay, so R just reverse the forward slash, you can say. And what is the name of my dataset? Iris, I think iris.csv. So if I call this iris, as you can see, our data frame is ready. That's how you can create a data frame using pandas. Okay, we have like indexing, of course. Then we have ID. Here you can see we have index here, means of course the default generated index, and we have ID, which is of literally no use. So we're gonna drop it. We have sepal length, width, petal length and width, and the target. What is our target? Species. Okay, so our data frame is ready, and let's move ahead. Let's find out their shape. Okay, and we're gonna drop this ID column because it is of no use. Like, just see how their shape changes. It is right now 150 by 6. 150 means 50 for each species. Okay, for iris setosa. Okay, for iris setosa, how many features you have? I mean, for like, of course, you have 4 columns. Apart from ID, apart from species, okay, you have 4 columns. 4 sepal length, sepal width, petal length, petal width. And for each species, how many features we have? 50. Just see here, 50. After that, 50 here till now, and after that species change. Okay, so that means we have data set for each species. How much? 50. So that's why we have 3 species, so 150. And how many columns does we have, including ID also? 1 2 3 4 5 6. So this is our target variable, this species, and we're gonna drop it. We're gonna drop ID. So it's gonna be 150 by 5, and of course species our target, we're gonna give it to y. Okay, y label. So for x, I'm gonna explain you what I'm saying. So for x, how many we're gonna have 150 by 4. Okay, I'm gonna explain you, of course. Beginners, don't worry, I'm here for you. So iris dot drop. What we're gonna drop here? We're gonna drop labels, that means id, and I think id is big now. And from which axis we're gonna drop? This is axis 1. Okay, column means axis 1, always remember. Okay, columns mean axis 1 and row means axis 0. So if I write here axis equals to 0, or even if I don't write here, then by default it's gonna take axis equals to 0 and it's gonna say id not found in axis. Okay, that means of course id is not there in axis now. We have 0, 1, 2, 3, 4. So we don't have we don't have any label name id. So we need to give axis name and axis equals to 1. Now let's see here. So if you run this, it's still there. Okay, so what you need to apply is this id is still there. So what you need to apply here is in place equals to true to remove it permanently. This is a method to do it. And then if you run this again, now it's permanently gone. So we have imported our data and made some necessary changes, and now it's time to visualize our data. So let's visualize, sorry for the spelling mistake, our data. Okay, let's first visualize it using scatter plot. Let me show you how we're gonna do data analysis here. Okay, that is plotly express dot scatter iris, and from iris what we gonna see is species, species, species. And what is species here? X. It means of course in x-axis we want to see species, and in y-axis we want to see, let's visualize this pedal width centimeter, and I'm going to explain what I want to show you, of course. See, that's how you do data analysis. Like that's what I'm going to just show you how you do data analysis. See this, we just called pedal width centimeter, means all the units are in centimeter. Okay, we just called pedal width 0.2, 0.3, 0.4 maximum. It is going for 0.5 for iris setosa, na? Okay, maximum it is going for like 0 for iris setosa. Maximum it is going 0.5, 0.6 maximum. I think I've just seen for iris setosa maximum petal width is 0.6 centimeter. For iris versicolor you can see 1.6 is maximum, I think. No, 1.8 is maximum, I think. And if you can see 1.9, 1.8, sorry. Okay, so iris versicolor is, for iris versicolor maximum size of pedal width is 1.8 centimeter. Okay, let's look at for iris virginica. Pedal width in centimeter for iris virginica is maximum, I think 2.5 maximum, I think. Let's see more. Yes, maybe 2.5 was maximum. Okay, that means for iris virginica maximum pedal width is 2.5 centimeter. For iris setosa it was, I think, 0.8, and for versicolor it was 1.8. Okay, so that's what it is showing. Okay, that's what it is showing. This is in y-axis, it is pedal width centimeter as we have defined, and in x-axis we have species. Iris setosa, versicolor and virginica. Now just see this. If you hover your cursor, that's the beauty of Plotly and of course Plotly Express. If you hover your cursor here in the first dot, it will show you species for Iris setosa, of course X. It just show you X and Y. Okay, in X we have species, and what is species? Iris setosa, and its minimum petal width centimeter is 0.1. I thought it was 0.2, but somewhere yes, it is 0.1. Okay, so minimum petal width in centimeter is 0.1, and if you go for maximum, you can see 0.6. Yes, not 0.8. We found 0.6 petal width for Iris setosa is 0.6 centimeter, like maximum. Okay, so petal width ranges 0.1 to 0.6 for Iris setosa. Similarly, we saw for versicolor, as you can see, minimum petal width centimeter for Iris versicolor is 1, like 1 centimeter. Like in petal width, Iris versicolor can go up to 1 centimeter minimum. Yes, and maximum I think we saw 1.8 now. Okay, so if you just go like second, minimum, third, and if you go for maximum, it will show you that Iris versicolor, like for Iris versicolor, its petal width can go up to 1.8 centimeter. Okay, that is how you classify between two flowers, and let's see how you can classify between, of course, all the three flowers. For Iris virginica, petal width centimeter, the minimum size of petal width in centimeter is 1.4, and maximum can go up to 2.5 centimeter for Iris virginica. That means petal width centimeter is like very large in Iris virginica as compared to Iris setosa. Okay, that's how you can classify between three flowers. And let's see petal width, petal height. Let's similarly, of course, you can visualize your data for any among those four features. Okay, in petal length you can see, let me show you one more thing here. It's very mess, but all right. Similarly, you can do anything. Let me come to again petal width centimeter, and let me show you one beauty of Plotly or Plotly Express. You can say that size you can define here according to let me run it again for petal width centimeter. Okay, size you can define according to its increasing size. Like 0.1 gonna be very small in size here in if you want to draw, and 0.6 gonna be large. Okay, in graph. So how you can do this is with ongoing size. Whatever the petal width size will be, just draw according to that. If you run this, you can see this now. Beauty of Plotly. 0.1 is very small in size, 0.6 is large. Okay, 1.4, and that's how you can just see and tell which one is very large. I mean, which one is larger. That's how you make data analysis very easier for any client. Okay, for any client. And similarly, you can do for like petal length, petal width. You can similarly do for sepal length centimeter and sepal width centimeter. Okay, let's see second graph, and it's bar plot. Let me show you the difference between you can do it, of course you can do it with Matplotlib also, but it's not gonna be not gonna be that much good looking. So let me show you difference between Matplotlib visualization and Plotly by bar plot. Okay, and you will see yourself why I don't prefer Matplotlib now, of course, because it's not appealing for me. And in x-axis, if you press here now, after writing bar, if you press shift plus tab, it will show you what you need to write. In x you need to give the x-axis, and height means y-axis. Okay, Iris, and in y we just gonna similarly call this. And species. Oh, sorry, spelling mistake. See this. If you hover your mouse, you just don't, you need to write some more commands to do that. If you hover your mouse, it's not gonna pop up any value. You just need to like analyze by yourself. Okay, iris setosa maximum pedal width in centimeter is in bar graph. If you are seeing this maximum pedal width in centimeter is like, you need to analyze 0.6 or it might be 0.7, it might be 0.8. So it starts from 0 and 0.6. And for versicolor, it's the maximum pedal width in centimeter can go like about 1.8, 1.9. Okay. And same for Virginica, you need to analyze by yourself. Okay, means 2.5. Okay. Now let's look at in Plotly Express how it's gonna look. Plotly Express, if you press tab, of course it's gonna show you. Yes, so just call bar and shift plus tab, and it's going to show you how you need to write data frame. You need to define, and then x and then y equals to. Okay, so data frame, what we have, iris x equals to, let me just copy that about thing. I'll just copy this now. No, sorry, this much only, and see yourself. Now you might get confused. Okay, this is 2.5 and it is showing like till 100. No, it is showing in something else way. It is showing like something else means, if you look at now, like for every feature, like if you are doing for pedal with centimeter, for iris setosa we have 50, for iris virginica we have 50, for iris versicolor we have 50. Same goes for all feature. Okay, so it is showing you all the 50 pedal width for iris setosa, all 15 iris versicolor, all 15 virginica. But you still might get confused, but then let me make you notice something, that it is smaller in size, because just look at this size of iris setosa. It is 50. It is 50. The box size is very small. Why? Because the pedal width in centimeters is actually very small. Just look at in the first box. Okay, what is the first box? It is saying 0.2. Here it is 0.2, first one. Okay, let me try to take a look at second box, still 0.2, and when it's gonna change, like it's 0.2 for like almost 5 box. Okay, 5 rows, and 1, second, third, fourth, even I cannot even see this. Okay, and in fifth, you see this box is little bigger. This 0.4 box is little bigger than this below it. Okay, so that's how scatter plot is, that's how Plotly Express actually creates the bar graph, most like in this kind of data set. Okay, if you look at the versicolor, of course, if you look at the versicolor, now you're gonna see more difference because the box size is not same anymore. No, let's directly look at into this one, because just see this one. Let me just you might notice that where it is, this box size, this, okay, 2.4 is bigger than, it's about 2 boxes. Just see this one is bigger than this 2. Okay, because their size is only 1.8. okay, and if you see, if you go in the data set, the first row for iris virginica belongs to 2.5 centimeter of pedal width, and if you actually go for iris virginica, then you can just clearly see that after iris versicolor, first one is for iris virginica 2.5, second one is 1.9, third one is 2.1, similarly 2.5, 1.9, 2.1. That's how this kind of data set, I mean, that's how Plotly Express creates bar graph for this kind of data set. Okay, so that's how you can analyze the data for like every feature. Now let's move forward. I hope you understand. If you don't, then leave down the comments, I'll answer. And let's move for the one more graph. Let's see how does iplot creates. Iplot means, let's see how does Plotly create, not Plotly Express but Plotly. As I said, now Plotly Express is the wrapper of Plotly. Plotly creating graphs in Plotly is little harder than Plotly Express. They both are like similar but not, still not. iplot, that's how you write. iris.iplot kind is equals to bar, and then we have x equals to, again I'm saying that if you press shift plus tab, it will show you how to write it. Okay, I just know how to write. So species and y is equals to, what was this, petal width. Let me just copy this. Oh, I'm so sorry. No, not much difference. Okay, not much difference. Okay, let's move forward and see how does line graph looks in it's not this. Let's see how to create line graph. Okay, the second last graph, this scatter, and we just need to do line, and we just need to erase this one. Same, almost same. Okay, same, you can analyze it like for iris setosa, start from 0.1 and goes up to 0.6. okay, you can see the index here. For iris versicolor species, starts from petal width starts from 1 centimeter and can go up to 1.8. Similarly for virginica, 1.4 to 2.5. Petal width can go for iris virginica 2.5 centimeter maximum. Okay, now let's move forward for our last graph, last one. Okay, scatter matrix, the last one. Oops. And how we're gonna rename them is simple, iris dot rename. Okay, and columns equals to, in dictionary format because we have multiple, so simple. And in what we're gonna change, we want to change them in, we just want to remove this centimeter thing. Okay, and let's do it for all the three remaining. We are now sorry, yeah, I don't need to hear it from this. I need to change from this, yes, and rename spelling is wrong, yes, right, it's now. Let's do it first. Who the hell is barking? This dog doesn't have any bark, I think. Okay, and I don't, oh, I messed anything. Oh, I messed up. I did it, and yeah, yes. Cursor was like, there was two cursor, no? So everything is completed, and let's run this. Rename got columns again. Yeah, spelling mistake again. Oh, happens with me. Columns. where I messed up. Where I messed up? Petal length. Yeah, I messed up here. Here I messed up, and sepal length, sepal width, petal length, petal width, and in place equals to true to make them permanent. Okay, if you now call this, and we have changed their name, renamed their name, and of course we need to change it from here, and then now it's not messy. Now just see this. You can actually analyze your data and compare data on hover. In Plotly you get this good thing, but you might get confused here. Iris settings are Virginica versicolor. I've hovered my mouse here and it is showing me from like, okay, let me show data closest on hover. Okay, let me explain you this. Green color belongs to Iris virginica. As I said, now color is equals to species, so it's just gonna give color to every species, different colors. Iris setosa belongs to, like, the blue color belongs to Iris setosa, green color belongs to Iris virginica, and this orange color belongs to Iris versicolor. Okay, now let me explain you how to actually analyze this data. Iris again, not looking at, okay, let me explain you this. Most easiest way, just come here. This is petal length. Okay, in x-axis we are seeing petal length here. We're gonna analyze this box, and what we're gonna analyze, this petal length. You might get confused, beginners might get confused. Let's analyze this petal width. This box we gonna first analyze. Okay, in x-axis we have petal length, and in y-axis we have petal width. So, and this we have 2, 4, 6, and this we have 0, 1, 2. Remember this. Okay, now let's look at for, like, for everyone, of course. 2. If like in Plotly, what does it shows? First the class name, then x-axis, then y-axis. In x-axis we have petal length. If, and you can see we are just going like before 2. Okay, so if petal length is equals to 1.7, and see the y-axis thing, petal width. Okay, and where we are seeing in 0.2, and let's just see this. Okay, we are under 0 and 1. Okay, so we are in 0.1, 0.2, 0.1, we are under that. Okay, so if petal length is equals to 1.5, and like sorry, if petal length is equals to 1.5 and petal width is equals to 0.1, under this condition Iris setosa falls. Okay, under this condition Iris setosa falls. And of course, for if you see petal length and sepal width, if petal length is, of course, again petal length lies below 2. Sorry, Iris setosa, petal length for Iris setosa lies below 2. You can see in petal length, you can see the whole box. Iris setosa is not going beyond 2. Okay, it is lying before 2 in every box. So, and in sepal width, you can also see in sepal width, for Iris setosa, petal length is equals to 1.9, and like you can see the maximum of sepal width. You can just actually analyze the data. So if petal length is equals to 1.9 and sepal width is equals to 3.4, it lies under Iris setosa. So you can all see there this. Okay, that for sepal width also, for sepal width, Iris setosa does not go here. You can see two line here, and here you can see sepal, for sepal width Iris setosa does not go below 2. this is the line number 2, this is the line number 2. Okay. So for sample width, iris setosa is not going below 2. Okay, the minimum it is going 2.3 for sample width, and the maximum it is going 4.4. Okay, so that's how you can actually analyze the data. Let's take one more box, and it's actually gonna take more time, so I'm just giving you like the brief idea, like just a small idea how you can actually analyze, and it's your homework to analyze everything, of course. Just see here for sepal length. Okay, for sepal length, for sepal length, no, let's analyze petal width, because we actually played with it na, 0.2, like we actually saw it more. For petal width, maximum it can go up to 0.6. So let's actually analyze this box. Okay, petal width, x-axis petal width and y-axis petal length. Okay, as we all know, setosa does not go beyond 0.6 in petal width terms. Okay, like for array setosa, the maximum petal width goes 0.6 centimeter. We actually saw before this graph na. In scatter plot we were seeing, we actually saw 0.6. where was it? Here, 0.6. in a scatter plot we saw no, that above, that the maximum iris setosa can go for like petal width is 0.6 centimeter. Okay, so and minimum it goes 0.1 centimeter. And if and for petal length and petal width, the combination of them is like this. This is the line number, this is the line of like 2 centimeter, this is the line of 2 centimeter, and maximum petal width, petal length can go for iris setosa is 1.9. So in this range of petal width and petal length, most probably it is iris setosa. Okay, and we analyze this box, right, if I'm not wrong. Okay, so in this range, most probably it is iris setosa. If you give your input to predict, most probably it is iris setosa. And let's see the confusing one, sepal length and sepal length. Okay, like this, sepal length and sepal length, or you can see petal length and petal length. It's nothing but it's like you can just literally ignore this, of course, because of course it had to draw na, so you can actually ignore this. Iris versicolor sepal length 6.0, you can actually ignore this for like same. If you want to analyze for same box, of course, sepal length is in y-axis, sepal length in x-axis, you can ignore this kind of box also. I mean, you can ignore this box, but for the cross, like for combination of boxes like this two, like this three na, we analyze sepal length with petal length. We can analyze sepal length with petal width, we can analyze sepal length with sepal width, but you can ignore this kind of box, like of course sepal length with sepal length, you doesn't make any sense na? It had to be drawn, so it draws. So our visualization is completed, and let's move forward for data pre-processing. Let me tell you, in decision tree, data pre-processing is not that much required. Let me just write it now. Data pre-processing. In decision tree, as of it is our first algorithm, data pre-processing is not that much required. We just need to do the label encoder. I will explain what this is, but we just need to do label encoder of like y, because of course any model takes data in numerical way. Okay, but we don't need to do this one hot encoder that much. Of course we don't need to do, and no, we don't actually need to do in any algorithm. I will tell you why, when we will need to do one hot encoding, but we don't need to do standard scalar in decision tree. Yes, we need to do this standard scalar in KNN, but we don't need to do standard scalar in decision tree. And this one hot encoding now we are not going to use for any algorithm. Like for all three algorithms, we are not going to use one hot encoding. I'll actually tell you when we're gonna use it. Okay, so but for decision tree we are not gonna use standard scalar. I'll explain you what this is. For KNN and clustering we're gonna use it. Okay, so let's move forward with data pre-processing. So let's start the pre-processing task and all right, so we have our data set, and so understand this one thing. This is our target variable. Okay, species is our target. Okay, and this fourth thing is our features. Like this fourth thing is our features and this thing is our target. So this thing needs to get separated from this. Okay, so we're gonna name a variable named, like we're gonna make a variable name as x or whatever you want to give, and we're gonna give all these features into that x, and we're gonna give all the like this species column to y. Okay, so because let me show you something. If I make able to draw, like say this is our model. Okay, and how to write this? This is our model. This is computer, let's say, or brain. Okay, whatever, brain. Okay, and we have all the features here x, and we have the labels y, and they are both connected. Okay, for beginners I am telling you. Okay, sorry for that. Like, and these are the features, and these are the labels. Okay, now let's take an example of the first data. Okay, 5.1, 3.5, 1.4, 0.2. let's just think like that your model is a brain, and the first data is going on to and your brain is about to get trained, like 5.1 and 3.5 1.4 and 0.2. that. Okay, now this is your first feature, and its label is, what is its label? Setosa. Sorry for that, Setosa. Let me write this by according to this, Setosa. Okay, so this first feature is going on here, and this brain gonna kind of memorize, not memorize of course it, but right now understand this, this brain gonna memorize it. Okay, this feature, if this feature comes, then that means it is Setosa. Similarly, it's gonna do for all the features. Now why not memorize term is accurate? Because it's gonna train the parameters, it's gonna train the what should I say, it's gonna train the patterns. Okay, like if in iris Setosa, the paddle width belongs from minimum 0.9 to 0.6. okay, as we saw earlier to 0.6. okay, and its petal length minimum belongs to like from 1 to 1.6 1.9. okay, and similarly its petal width belongs minimum from 3 up to 3.8, most probably maximum, no, 4 also, 4.2. and similarly sepal length minimum it starts from I guess 4.4 and goes maximum 5.1, 5.7 maximum. Okay, maximum 5.7. So if this pattern comes, okay, from minimum to maximum under this range, then it belongs to iris setosa. Similarly, it's gonna do it for versicolor. Okay, like if sepal with sepal and petal with petal length comes under like its minimum to maximum range, all the four, then it is iris versicolor. And similarly for iris virginica. Okay, so now even if you give a random input to predict, like even if you give let's say something which does not belongs to this thing, okay, like even if you give 1111, so still it's gonna predict accurately because it has analyzed the patterns. And even if we give 1010, means even if we give input to predict what could be the outcome, even if we give 1010 or 1.7, like any random combination which is not there, okay, just to test what's gonna happen, so it will actually give like most probably accurate answer because the model has analyzed the patterns so well that it knows like anything comes in this range, then it belongs to a certain class. Okay, so that's how the model works, and that's what we're gonna do. We're gonna separate our features from like whole data set, and we're gonna separate our labels from it, and we're gonna give it to x, like variable name x and variable name y. Okay, let me close this to train by our brain. Okay, so let me close this. Now let's create a variable name x, and x equals to, we're gonna give all the features of iris, so iris dot, but we don't want to give this species, so iris dot drop. What we're gonna drop? Species. That means it's gonna store all the things from iris except species. We have already dropped id name, you know, earlier we had this id, and we dropped it earlier, so now only method. Oh, I'm so sorry. And from which axis? And simply this. Oh, and from axis 1. Yeah, so if you call x now, we'll see this. Okay, the species is gone, and now you have all the features only. So we have x now with all the features, and now it's y time. From iris we took like all the features, okay, and we stored in x. Now it's time for species. Like we have like in iris, now it's time for species. So what we're gonna do? And first let me put y here, and species y, oh sorry, y is equals to and if I call this y here, so now we have x with all the features, and we have y with all the labels. Now understand this, model doesn't know what is sepal length, sepal width, petal length, petal width. Okay, so we need to convert it into numerical form. It is in numerical form, that means we need to remove this. Okay, and model doesn't know what is iris setosa, iris virginica, and iris versicolor. That's where we need to do label encoding. That means we need to convert this labels into a numerical form. Okay, that means model gonna take model, of course model use actually takes any data into numerical form. So we need to convert this into numerical form. For iris setosa, the label gonna be 0, for versicolor it's gonna be 1, and for virginica it's gonna be 2. Okay, so that means when the when any input you give to predict, model will gonna give output in the numerical form. Okay, so if you give anything to predict like 1 1 1 1, okay, then model will gonna give output in numerical form. If it is like if that feature comes under label 0, then it's gonna give 0. Okay, that's how it works. So after converting it into label in numerical form, it's gonna look like this. For iris setosa, it's gonna be 0, because you know iris setosa comes first in data set, and then iris versicolor, then iris virginica. So iris versicolor gonna be 1 and iris virginica gonna be 2. Okay, let's do this. So always remember that models, like your training model or whatever you say, that any algorithm, any model takes data into numerical form. Okay, from sklearn dot preprocessing import, what are you gonna import? Label encoder. Okay, and give them a le equals to label encoder. That's how you create an object. Now y equals to le dot fit transform. That's how you transform them. Transform, and what you want to transform? Y. Okay, then you are storing it again in a y. Okay, let's see. And now see, that's how you convert your labels into, like your string labels, into numerical form to give your model to train. Now it's time for X. Okay, one more thing here. There is one more term called one hot encoding. One hot encoding, let me tell you what happens. Okay, I'm not going to store it into y, so I don't want to. Okay, so one hot encoding does just convert it, like setosa in 100, versicolor in 010, and virginica in 001. There is a different use of label encoding and one hot encoding. Where to use label encoding and where to use one hot encoding, you can just have a look at Google, but here we're gonna use this. And now it's time to convert X. Okay, it's simple. When we will do KNN, I'm gonna show you what does this standard scalar means and how to convert your X using the standard scalar, and what does actually happens when you do it. Okay, but right now we just gonna convert it into NumPy array, and means in a numerical form to give the data to train to model. X equals to np.array, and there we go. If you call this, here we go. We have, like for setosa, you can see now model doesn't know it's setosa 5.1 3.5 1.4 0.2 5.1 3.4 1.4 0.2. the model doesn't know this is setosa or this is versicolor or anything. It's just gonna do one thing, that is just gonna take first feature and it's just gonna memorize it. Yes, it is 0. Then it's gonna take the second feature and it's gonna memorize. Now again, memorize is not a right term, but anything that comes in this range, okay, for 0 it's gonna train it so well that even if you give a random input, okay, in this range, it's gonna predict that it is 0. And we know that what is 0? What is 0? Your setosa. Okay, and same for 1. I don't know from where 1 starts here, but for example, if 1 starts from here, just for an example, no, I don't think so. 0.6, no, it was the maximum. Yes, 1 I think almost starts from here, because just see the difference from here. So it's model gonna train it so well that anything comes in this range, it gonna label it as 1. It's gonna train itself it. Okay, so it's gonna train it to, like, in such a way that if you give input in this range, it's gonna predict it as 1, and we know what is 1? Iris versicolor, and 2 same for Iris virginica. So now we have X ready and we have Y ready. Almost everything is done in pre-processing. Only one thing is required, that is split the data into training and validation. Okay, or you can say for testing. I think I did for testing. Okay, let's split the data for training and testing. So from sklearn, and I hope I am clearing many things for like every beginners. Okay, like I hope my teaching is now actually clearing every small doubt of every beginner. But even if they have doubt, then still alright, they can ask me. I'm there for help. Now how we gonna split? I'm gonna explain what does this xtrain and xtest means, and ytrain. Just let me write, okay, and ytrain and ytest means. And now remember one thing, that I've given small y here and capital X, because seriously I don't know why people give like this, but I really don't know. Even in ytrain I've given a small y, and in xtrain I've given capital X. I just don't know, but everybody gives, so yeah, even I've given. Train, test, split. I'm gonna explain what I'm doing, but still test size gonna be 0.3. all right, and random state gonna be 0. okay, what does this mean? What we want is, we want like some data for training and some data to test. Okay, there is one more thing called validation, when we cross check what we have trained, but we are not cross checking it. We are using some data for training, like 70% of data for training, and 30% we are leaving it to test, to predict if we have trained it or trained it accurately or not. Does the model actually got trained accurately or not? So how we did xtrain means this is x, and this is the thing for training. Okay, this is the thing for training, and xtest means its labels. No, sorry, xtrain means features and ytrain means labels. Understand this? Okay, x means features and y means labels. Same way, xtrain is for training and ytrain is its labels. Xtest is for testing and ytest is their labels. Okay, and how we divided them is train test split. By train test split method, divide x and y, okay, into x train and x test means, and test size is what, 0.3 means 30%, okay, 30%, like in ratio of 70-30, divide x and y into, like divide x into x train and x test, okay. For like training we are taking 70% and for testing we are taking 30%, okay. And same for y, divide it for like whatever you are dividing, like whatever feature you are giving, give the same labels according to, like, of course, to y train means label for training, and for testing whatever we wanna test, give those labels to y test, okay. Now what is random state 0 is simple. It doesn't matter what integer you give. Sometimes you, like I have seen in like random state is equals to 42. It doesn't matter if you give 0, 1, 10, 50 or whatever. Just understanding, when random state set to an integer 0 or 100 whatever, train test split will return same results for each execution. I'm gonna explain this. And if you set it to none, no any, then train test split will return different result for each execution. Means when, if I run this, okay, if I run this, and yes, if I now run this, yes, I have like randomly it had picked x for like for x train, okay, 70% it has randomly picked, and for x test 30% it has picked randomly, okay. So if I give it none, then every time I run it, it will have a different number. But if I have given anything integer here, that means once I run this, then I will get every time same number. That's all. Some of might get confused, but don't think about this that much. That's all. But just clear your agenda here, okay, that we need to divide x and y with x train for 70% of training, and y train its labels, and x test for 30% of testing, and y test is its labels. And so let's see the size of, first see what was our size of x, okay. What was the actual size of x, you know, we did this. So what was its size? 150 into 4, 600. Now after dividing it into training like 70%, now look at its size, 420, okay. Look at its shape, 105 by 4. Earlier of the shape of x was 150 by 4. Now giving it 70% to x train, the x train shape is 105 by 4. And same for testing, 45 by 4, you know, 70% means 105 of by 150, and 45 is like 30%. And look at this size, 45 into 4, most probably 180, okay. So we are done with our pre-processing task. So what we have done, we have imported our data, we have visualized it, and we have pre-processed it by we gave features to x, we gave labels to y, we transformed y and x into their, like we transformed y with a label encoding, and you learn one hot encoding separately, like just Google it, or one hot encoding has its own value, and we converted x into NumPy array so that we can give data to train. And I'll explain you what is standard scalar, okay, and I tried to explain what is one hot encoding. It just converts your data into array form, and then we split it the data. Now it's time to train the model. Okay, now it's time to training the decision tree, as this is our first algorithm. Okay, let's build our first model, that is decision tree. Okay, other two models are KNN and clustering using k-means. So let me tell you what is decision tree in a single minute, and I want you to learn the maths behind decision tree. Okay, because like what is entropy, okay, and how does Gini, what is Gini index and all. Okay, so but in a simple way, let me tell you what is what is decision tree in a much simple way. Okay, it's just like true or false. If it is true, then do a certain task, or go for another decision, or false, then do a certain task. Okay, like see this example, like for better, is a person fit? I hope you can see this example. Let me just open this, and credits to the owner of the website. No, better in this way. Okay, is a person fit? Okay, is a person fit or not? Then if age is less than 30, okay, like it's just like true or false. Okay, if age is less than 30, yes, and another condition comes, eats a lot of pizza, yes, that means unfit, or no, that means he is fit. Okay, it's just like true or false. If age is less than 30, true, it's a lot of pizza, true, then unfit, false, then fit. Same, if age is less than 30, false, that means no. Exercise, does he exercise in the morning? Yes, then fit. No, means unfit. That's all. Okay, decision tree is just that's all. But I want you to learn like what's happened behind decision tree. Okay, like what is Gini index, and let me just try to I don't think I can just find it. Okay, like this, but I want you to learn the maths behind it. I want you to learn what does happens behind. And one more thing, decision tree, and I am suggesting you some playlist also to watch that. This well, they have not paid a single money. Okay, they have not sponsored this video. Nobody is sponsored this video. It's just that I found them useful. Edureka YouTube channel, 46 minute video on 46 minute video. Okay, they might be having multiple videos of like in decision tree, but this 46 minute video, they've explained like many things about decision tree. Okay, like what is Gini index, and what is leaf node, and what is impurity, purity. Second, and one more I just want to suggest, one more only. It's just
so let's manually build a decision tree for our data set. So there's a data set which consists of 14 different instances, out of which we have 9 yes and 5 no. Alright.
Ignore this.
So we have the formula for entropy. Just put over that. Since 9 yes, so total probability of yes equals 9 by 14, and total probability of no equals 5 by 14. And when you put up the value and calculate the result, you will get the value of entropy as 0.9. Alright, so this was your first step, that is compute the entropy for the entire data set.
First, now you saw this Edureka video, and then I'm suggesting you this decision tree Krishna of playlist from machine learning. Yes, tutorial number 37 also, but there is a playlist he has created of like machine learning. Sorry for the spelling mistake I just did. yeah, complete machine learning playlist, and
Hello, and
you will find related to like
course is the most
let me just tell you past. Otherwise, you can just
hero in learning
here you go. Okay, from here, yes, tutorial number 37, 38, 39, 40. And
according to a recent survey
alright, 37, 38, 39, 40. First was that Azure video, then refer to him.
Python is
Okay, for like in-depth learning of everything. That's why.
Whether you want to perform
that's why
automation,
Krishna next. Okay,
data science, machine learning, web development, or more.
Okay, alright. Let's move forward to plot our descent rate. First Azure video, so that you can just get all the surface level thing. Okay, what is happening behind it and all. And then for in-depth, go for his Krishna video. Okay, he's like really awesome. Okay, let's import from sklearn import tree. Tree means our decision tree, or not tree. From sklearn import accuracy. Let me import it above. Above means there, for like, of course, for all the three algorithms we want to apply. What's this type one? Is by accuracy dot matrix. Oh, sorry, dot matrix. Now let's give the name of let's give a name to our decision tree classifier. I am giving it DT. Alright, okay. And for KNN, I'm gonna give KNN only. And clustering, I'm gonna give K-means. Tree dot DC and tree classifier. Okay. And you just saw one more thing, that tree dot decision tree regressor also for regressing purpose. Okay, for regression type of problem. You know now that in supervised learning we have two things, classification and regression. Import. So decision tree is also used for there. Oh, sorry. Classifier, and here we go. Okay. Now that's all we need to do. Okay, like we just called the classifier and stored it using DT. Okay, now how we can train? For beginners, I am telling you, fit xtrain. Okay, means our training features with their training labels. That's all you train, nothing else. Okay, and now it's time to predict. Like let me just run this, shift plus enter, and I think okay, you have just trained your model. That's all. Okay, and let's now predict their accuracy and all. Okay, prediction DT, I'm giving the name prediction DT is equals to DT dot predict x test, and I'm gonna explain, just be with me. Okay, accuracy DT. Why accuracy DT? Because like we are gonna use three algorithms, so I just gonna name according to them. Score, and I'm gonna explain, just hold on with me. Why test, and what is the prediction DT. Where it is into 100. Okay. Let me explain you the simple thing. Okay, you understood? Tree dot decision tree classifier, we just called the classifier and then we trained the model, the decision tree classifier by using dot fit. That's how we train. We train xtrain, means what is our xtrain? Of course, the training features with their training levels. Okay, now it's time to predict, and we give the name we just made a variable called prediction dt, and what we predicted, that we predicted whatever it trained, okay, like in using this, whatever this classifier learned, it should predict on X test. What is our X test? You know now that we separated our features 70% for training and 30% for testing. Okay, so we trained our model using this 70% of data, and now it's time to test our model using this 30% of remaining data. Okay, so that we can know if we trained it correctly or not. Okay, we trained it, and now it's time for testing. So so whatever we trained, we are now predicting it in the test data. Now accuracy, now we need to find the accuracy. Okay, so we are comparing the y test label, means now let me just tell you. Okay, means y test means x test means the 30% of remaining features, and y test means its labels. Now y train is the labels of x train. So what is y test? Y test is the labels of x test. Okay, so we are going to compare y test, okay, with prediction dt. Okay, so that means this is our y test, and how much prediction dt actually predicted correctly our x test. That means we just gonna do, let me just show you. Okay, now accuracy dt 97%. That means now you can understand now better. First let me call this, and then oh sorry, I could have called it. So what we compared is, this is our y test data, okay, and this is our prediction data. So we compared it, like how much prediction how much our classifier predicted on x test accurately according to y test. Okay, like in y test there is in our x test the first feature belongs to iris virginica. Okay, like we can see in the y test now its labels. Okay, so the first, and what is to iris virginica. Okay, our model predicted it correctly. Second, you can see iris versicolor. Okay, our model predicted it correctly. Okay, but here we are comparing y test with prediction. Let's see how much correctly our classifier predicted. Okay, so we are comparing it till here. Okay, both are till here it is matching with y test, but let's see where okay, here we go. Okay, till here prediction dt is matching, its answer is matching with the labels of x test, that is y test. Okay, but here you see, here our classifier has predicted the iris versicolor as iris virginica. Okay, here one mistake our classifier did, and okay, that's all. That's why our accuracy is not 100% but 97.77%. Okay, so that's what we just did. We compare the classifier prediction. We compare classifier prediction with the y test. Okay, so that we just wanna see how much we predicted accurately. Okay, like if our answers is matching with y test or not. That's all. So we just did our training using decision tree, and before I show you how to predict any random value, if you give, like, even if you pick up a flower and if you scale their feature, okay, and if you want to predict it using decision tree, okay, and how to do it, before showing you that, let me show you how to visualize the decision tree like this. Where it is? I think I need to run this again. Okay. Let me run it. Okay, here we go. I just ran what I made. So let's visualize how, let's see how to visualize our decision tree model. Okay, you can see the class name Iris Virginica, and you can see then Iris Atosa. Let's see how to do this. Okay. Input OS. Let me do it for everyone. Input OS. Now OS dot simple environment. Equals to OS dot path plus, here we need to give the path of what we need to give is, for visualization you need to install this GraphViz. Okay, GraphViz 2.38 you need to install. Okay, this one, and then you need to install this one, you need to install. Okay, and where I have installed it, C Python 37 I think, and yeah, GraphViz, and bin this folder, the path of this folder you need to provide there. Okay, and there we go. R, so that it took it in. Now you need to install GraphViz using pip also. I guess if it doesn't import it, then install it using pip also. Okay, install that software and install it using pip also, like both. I don't know, but install it using pip also. Pip install GraphViz, that one also. Tree. Now tree dot export. Now what we are dot data means I'm just giving the name. You can this data, you can give it anything. With this, that does makes more sense. Export, tree dot export graph. That's how you call GraphViz. Okay, and what DT. Okay, DT, or decision tree classifier, and after training you can only visualize it. Okay, like after training means after fitting the model, means after training only you can visualize graph. Okay, out file none. Yeah, features name. Now feature names equals to what it is, iris, whole iris, but drop what, let me see what does it contains in iris. Yeah, we need to drop species. Okay, drop because that's our target, not feature. Species and from where x is 1. Now I explained you earlier. And dot keys and what class names. First names is what iris species. From iris call species, that is our actually the class name. No, okay, we dropped it here so that we can take remaining thing to these feature names. And now class name only we want iris species because that is the target. No, dot unique means suppose take only unique thing. Field is equals to true and rounded is equals to true. Special, I'm going to explain you everything this thing. Okay, just hold on. That special character is equals to true. Now just see what happens if you write now iris unique iris. Only like it just wanted the name. Okay, this graph which doesn't want like the 150 times, sorry, I mean 50 times iris setosa, 15 times versicolor, 50 times virginie. It doesn't want. It just want like the names only. And let's see. It's not called. Yeah, sorry. Now to see this, we need to call one thing here like graph with dot source like this. Okay, let's see. Graph with dot. If you press the tab, then you can see sources, of course, source and what with data. Okay, we got this. And before explaining you this, let me show you what happens if you do field is equals to 4. Let's see. Yeah, you don't see the colors. Okay, and it is not looking that much good, so let me do again too. Okay, and if you round it false, okay, it's showing in box. Whatever you like, you can do it. And true and special characters, let's see, false. Not much any difference, I don't think so. And comma, shift plus tab in Jupyter, and you will see like what else you can do. Labels, false impurity, proportion, yeah. There are some more things there, but alright, we are not going into that much deep here. Now let me tell you how, like what this tree is telling you. Okay, I think I need to do this. Now understand this. First one, it took like and why it only took this much data, you will understand when you know the maths behind it and what is happening behind it, like what is information gain, what is Gini index. Okay, but understand this right now if you don't know the backend part. Petal length is less than or equal to 2.35. okay, petal length. First one, it took whatever data it has, like first like petal length should be less than or equal to 2.35. okay, and how many samples does have petal length less than 2.35? Even you can see like it has written 105 and 105 among how much? Among almost fully. not homosphily, of course. Let me show you. Okay, so among 150, okay, now don't get confused that from xtrain it is taking. No, what we have given full features name, like okay, like all the features including xtraining, x testing also, and the class name. Okay, so it has taken all the things from Excel file, but on what basis? After training. Okay, after training it will visualize, it can visualize the whole data. Okay, not only xtrain, not only xtest, but it can visualize whole data. It will extend its nodes, or you can say it will extend its branch till it found or it finds Gini index equals to 0, 0. That means the impurity value equals to 0. Okay, till until it find Gini equals to 0.0, it will keep extending its branches. Okay, and see, at last it found like 0.00, and there it has stopped. See also here, no branches from here, but from here now, but from this box 2 branches are still there. Okay, but and see here, from here no branch is like going out, from here no branch is going out. Okay, now understand this. So now how much in among 150, like 54 Setosa, 54 Versica, 54 Virginica, how much, like how many samples does have petal length less than or equal to 2.35 centimeter? So 105 samples have petal length of less than or equal to 2.35 centimeter. But now see this, how many like from that, how many does belongs to Setosa? 34. Okay, how many does belongs to versicolor? 32. And how many does belongs to 39? Now why it is written class equals to Virginica? Because simple thing, because Virginica is in like the sample size which belongs to petal length of less than or equal to 2.35 is larger than these two, but Gini index still not equals to 0. Okay, there is still impurity. So it has extended its branch. If petal length is less than or equal to 2.35, true. Okay, so in Iris Setosa the Gini index is 0.0. Okay, so that's why that class belongs to Iris Setosa. Okay, so if you give the input to predict, and if its petal length is less than or equal to 2.35, that means that flower belongs to Iris Setosa. Okay, now if false, okay, if false, then it will take another condition. If petal length is less than or equal to 4.95 centimeter. Okay, and how many samples from 150 here? 71. Impurity is still not 0. Okay, so why there is value 0? Because like all the samples of Setosa belongs to less than or equal to 2.35. Okay, so now we have only 2 remaining, 32 and 39. Okay, 32 of Versica, 39 of Virginica. Okay, and it is showing class equals to Iris Virginica because it thinks that most of the samples belongs to Iris Virginica, so it might be, but still Gini error is still there. Okay, Gini impurity is still there. So true. This is a true thing. Okay, petal length is less than or equal to 4.5. True. And you can see then it will take another condition. If petal is less than or equal to 4.95 and petal width is less than or equal to 1.65. Okay, here, and for false thing, if petal is equals to less than or equal to 4.95, Okay, if it is false, then it is giving another condition of if pattern length is less than or equal to 5.05. Okay, now just we are coming here. Okay, for true condition, for false condition. For true condition, it is giving two more conditions, and for false condition, it is giving two more conditions here. Okay, let's see this. If sample width is less than or equal to 2.75, if it is true, then you have 0 offset, of course, because it has already been allotted there. 1 for versicolor, 3 for virginica, but still impurity is still there because it is not sure that of course which class does it belongs. Okay, and for false, see here. Okay, and for false, if petal length is less than or equal to 5.05, false, that means no virginica, okay, just see here. Okay, petal length is less than or equal to 5.05, false. 33, no iris virginica means 33 of iris virginica does not have petal length of less than or equal to 5.05. So if you give input like this to predict, and if it contains petal length is less than or equal to 5.05, so it's just gonna give the output as iris virginica, and if it's false, then here we go and here we go, like this. So that's how our decision tree just goes on. You need to actually sit and understand all these things. Okay, even if you see here, sample weight is less than or equal to 3.1, then how many samples we have? Only 4. Okay, most of them belongs to iris virginica. But if it is true, sample weight is less than or equal to 3. If it is true, then all the class belongs to iris virginica, and if it's false, then only one. Of course, we got iris versicolor. So how many conditions it actually took to predict that it is iris versicolor or it is iris virginica? Okay, petal length is less than or equal to 2.35, false. And if it is true, okay, petal length is less than or equal to 4.95. If it is true, okay, then it will ask another condition, petal width is less than or equal to 1.65. If it is false, okay, if it is true also, then it is iris versicolor. If it is false, then it is iris virginica, it might be. Then it will ask another condition, because still there is impurity, so it might. Okay, sample width is less than or equal to 3.1, then now again, if it is false, then it is iris virginica, and now Guinea impurity is equals to 0, so it is iris versicolor, and if it is true, then it is iris virginica. Same goes here. So you just need to sit and you actually need to analyze the whole data, then you will understand better. Okay, you might get confused here, but alright. Let's predict the model outcome by giving it random data. Okay, as you know that our model gonna give outcome in numerical form, so we just gonna I will tell you what I'm doing. Iris Satosa I don't know the name again. It's right for versicolor also. I mean, yeah. What? Color. Sorry for spelling mistake or whatever it is. Okay. Now, if you give xdt, okay, or xdt or x data is equals to, if you want to take the test like for any individual flower. Just let's see, just let's take like, if you just want to give any random input, now let's just give this 5.73. okay, 5.73 and 5.7, where it is 3, 4.2, 1.2, and it is actually belongs to vertical, na? So let's see if it can predict or not. 4.2 and 1.2, yeah, 1.2. There we go. Now let's see if it can predict or not. So what we're gonna do, what we're gonna give is x dt. That means just to understand, like decision tree x data numpy array. Why we need to convert it into numpy array? Because our feature was in array form. Okay, even y and x. So that's why numpy array and in 2D array, of course, because our feature was in 2D array data. Okay, and alright. So prediction xdt prediction. I should give name so that nobody gets confused. xdt prediction is equals to classifier dot predict, means predict what you need to predict is xdt. That's all. And let's see. Oh, sorry. And what we just did. Oh, I understood, because don't do mistakes like me. I just did data. Here, see, it is already under that now. So either you can just like simply do your random stuff, or you should give directly it here. Okay, I just wanted to make it more suitable. Alright. So now we're gonna give a random input. Okay, or like you can just give, if you found a flower and if you scale its feature. Okay, so if you scale its feature, so you are giving it to predict. Okay, so I just ran this step now. Now let's see our prediction. X dt prediction array 1. Array 1 means vertical. If there is 0, then it is setosa, and if there is a 2, that means vertical. And where we took the data from, I guess from here now. Where was it? What was it actually? 5.7, 3.4, 5.7. Where? Somewhere from. It's just lost. No, it's not 4. 5.7, 3, 4.2, 1.2. Yeah. Okay. 5.73, 4.2. That means this. Some space. Yeah. 3, 4.2, 1.2. Okay. So this belongs to 1, and if I just do 0 to make it a integer. Okay. So 1 like this. Okay. So it belongs to vertical, and let's print it in a good way, of course. Category integer. Vertical. Okay. Now let's test for 1111. I don't know what's gonna be the output. 1111. Okay. Let's see. Let's say you found the iris flower of feature. Okay, petal with petal length, or like from sepal and sepal with 1 petal and petal with 1. Okay, let's see. It belongs to iris setosa. Okay, so that's how you can actually predict your custom input. Okay, so our decision tree classifier is completed, and let's move forward to solve KNN problem. Okay, K nearest neighbor and before doing prediction, I'm going to explain you, as I said, what is KNN. So our descent tree classifier was like really easy, and you just need to sit and understand this. This is really easy for first time. It might be confusing for you, but it is really easy. Okay, it took me like 10-15 minutes just to understand this fully. Okay, so let's move forward to solve our KNN problem. First, let me write K nearest neighbor algorithm, and let's see what is KNN algorithm. Okay, so first let's understand what is KNN algorithm means. What is KNN? KNN is the simplest machine learning classification algorithm that I think you, after decision tree, you will ever gonna face. Okay, KNN algorithm is very simple to understand. Let me show you. You will understand in 1 to 2 minutes only, but I want you to know the maths behind, I want you to know what is Euclidean distance, what is Manhattan distance. Okay, what the backend part I want you to know, but right now understand this. Okay, like you want to know, for say this point. Okay, of course this is just to show you. Suppose this is a fruit. Okay, and you want to know if this fruit is orange or this fruit is mango. Okay, so you want to predict through your machine learning that if this fruit is orange or this fruit is mango. Okay, so what you do is you set a value. K means the neighbor's value. Okay, like the minimum distance you want to go for. So K is equals to 3. So as you set K is equals to 3, so just right now focus on this circle. Okay, don't focus on this bigger circle. When we will take K is equals to 6, then focus on that. Okay, right now focus on this K is equals to 3 circle. Okay, so from all the data points, okay, those 3 points, those 3 only, because we have taken K equals to 3. So those 3 points which is in the minimum distance with respect to this point will be considered to predict the class of the fruit. Okay, and understand again, when we set K is equals to 3, that means we gonna see those 3 points here, okay, which is in the minimum distance with respect to this point. So just see here, K is equals to 3. K is equals to 3. So the first point which is in the minimum distance, I think this one. Okay, so the algorithm considered this, then it goes for searching the minimum, that point which is now which is near to this point. Okay, so this one and this one, only 3, because we said K equals to 3. So now among those K equals to 3, 2 belongs to class B, that is our mango, and 1 belongs to orange, because only one point is there now, that of class A. Okay, and that is this yellow color. So this fruit is more likely to be a mango than orange. Okay, now when we consider K is equals to 6, okay, now our data points are bigger. Okay, our parameters are bigger. Now see that when we set K is equals to 6, so among all these points, okay, what are those points which are very near to this point? Okay, what are those 6 points? Okay, among all this one, which what are those 6 points which are near to this point? So these are first 3, and then the algorithm gonna search for the fourth nearest point, and that is this. Okay, like after all the points are there, na? So it begins like it's searching, and it found the three nearest and fourth, and I think this one is should be the fifth, or this one, I guess. Okay, fifth point and sixth point. And if we set the value of k equals to 7, then it's gonna take this point also. Okay, and if we set the value of k equals to 8, then the model gonna consider, I think, this point also. Okay, this is more far than this. So that's how KNN works. Okay, it runs on the basis of which data points are more nearer to the to that point which we want to predict. That's all. Okay, now let me just explain you one more time. Okay, just in 1 minute, by seeing you one more graph. Otherwise you can just go 1 more minute, fast forward it. Okay, see this. Initial data is this. Okay, now we need to calculate. Okay, like what are those points which is nearer, and we want to calculate, like we set the value of k equals to 3. That's all. Okay, so now it's just gonna calculate it's gonna calculate. First it's gonna see where are those points. First it's gonna see where are all those points and who are here. See in this, who are at the minimum. Okay, first it's gonna consider everything, every data point, and okay, which is like class A and class B, and it's gonna consider all the points. And now, as we have said, k is equals to 3, so it's gonna take those only 3 points which is very nearer to this point only, and it's gonna leave the rest of them, like other apart from 3, it's gonna leave. Okay, now in this, see this. Okay, what are those points which is nearer to this point? What are those 3 points? So 1, 2, 3, and rest of the thing is of no use. Okay, so according to this point, okay, or this input belongs to class B, because in those k equals to 3, two points are like in majority. Okay, so according to this belongs to class B. But if we like consider that if we set k equals to 5, then that means what are those 5 points which is nearer to this point? So 3 are already there, and I think this might be the fourth. This might be the fourth. Of course, the model will calculate, but this might be the fourth, and this might be the fifth. I think this might be the fifth. Okay, still even if k equals to 3, k equals to 5, still this 3 will be in majority and this 2 will be in minority. So this input or this point belongs to class B. Okay, so that's how KNN works. K nearest neighbor works. So I wanted to know the backend part. And all. Okay, so let's move forward. And okay, let's start our model training from scalar dot neighbors import KNN classifier. KNN is also used for regressor. Okay, regression purpose. From learn dot matrix. I don't think we're gonna. Oh yeah, of course we got. Accuracy we have already defined above, no? Alright, we don't need it. So how we used to call our classifier in decision tree, like this, tree dot decision tree classifier. Now what we need to do is, how we need to call it, let's say KNN is equals to k nearest neighbor classifier. Why the dog is barking? Neighbors equals to neighbors equals to 5. Okay, like k is equals to 5. That's all. K is equals to 3. I'm gonna show you what is the best value of 5. Like you cannot decide now. Like maybe 3, maybe 5, maybe 7, maybe 8, maybe 4, maybe 2. So I'm gonna show you how to choose like what could be the best k value. But before that, let's just take 5 only. Because we need to understand some more thing before knn. Alright, now knn dot fit. Again here comes the standard scalar part. Okay, before giving fit model, like fit thing to train xtrain by train, I want to tell you what is standard scalar means. Okay, let me just show you here. There it is. What is standard scalar? I hope you have heard about standard normal distribution. Okay, this is a very simple maths. Standard normal distribution. Yes, the very simple maths. We kind of divide the numbers on a standard normal way. Okay, that's all. And let me just call knn again, and because I want to tell you why we need to do standard normal distribution of the areas of x. Okay, now understand this. Let me call iris also. Iris dot head 3. Okay, understand this. In k nearest neighbor, okay, one point, like every point should be in a range so that our classifier can find the nearest points. Okay, but what if like in this units are in centimeters, so we don't have to apply standard normal distribution. And I'm gonna show you what happens after you apply. But understand this first. We don't have to apply standard normal distribution because their units are in centimeters. But what happens if you are going for another project and the first features have the units in kilometers and another feature have units in centimeters? So the difference is very huge. Okay, difference of kilometer and centimeter is very huge. So in that case, you need to scale down the kilometers and centimeters into a particular range so that they all become like in a equal way. They become almost equal. Okay, you need to scale down. There is one more thing called normal distribution. What do you say? Normalization, where what you do, you just make like this is 5.1, this is 3 point. You do 0, 1, 1, 0, 0, 1, 1, 0. You divide everything with 1 or 0. That is normalization. But here I'm talking about standard distribution, where this is 5.1, this is 3.5. Now here we will actually scale down these values under -0 point. Okay, under like from -2 to +2 +3. That's all, only that. Okay, so the difference will be very low. Okay, even though if you are dealing with a project of like once units is in kilometers and another once units is in centimeters, so you need to scale down everything so that they all become like equal. Their difference can become very low, so that the classifier can actually access to all the data points. Otherwise, if someone is in centimeter and another was is in kilometer, somewhere around here, so it's not possible to predict, no? So that's why you need to scale down everything to come under a particular range. Okay. Here we don't need to do this because units is in centimeters and the magnitudes of 0.2 and 5.1, the difference is not so that much large. Okay. But still I'm gonna do to show you what happens if like how to deal with that and how to actually do that. That's my major concern. Okay. Here is our x value and train. Let me just call train. Like first two value, no? So first two value 0 to 3 only. Right? Oh, sorry. Damn it. From 0 to 3. Yeah. And there we go. Okay. Let me pull down it again. Little more. Yeah. No. Sorry guys, even I don't know what I'm doing. Just hold on. Yes, here we go. Okay. Alright. Let me just pull it little up. Yeah. Now here we are gonna do standard normal distribution. Okay. From sklearn.preprocessing import standard scalar. That's all. Okay. Now SC I'm gonna name SC is equals to standard scalar dot here dot fit x train. Here what does it means? Okay, let me just again what I'm saying is here standard scalar dot fit x train to analyze the units, as in units in centimeter, but it needs to analyze, okay, units and the feature parameters. Okay, it will analyze like how the features are distributed, and on the basis of that it will distribute it, and it will distribute the x test also. Okay, right? In this line it will analyze the patterns and units and of course magnitudes and units, and x, let me name x train std. Okay, and sc dot transform. Here we're gonna transform it x train. From this line it will analyze the units and magnitudes. Okay, and in this line it's gonna, and according to the analyzation of x train, it will not only transform it, but it will also transform test data. All right. So as insert side below, let me just copy. Oh shit. Okay, all right, and yeah, as let me just bring down there. Okay, as just C, and now C x train std, the first three. First let me show you what happens there. What just happened there? Yeah, it has distributed the x train with normal distribution. Okay, and just see the difference. Okay, The first feature was in 5.2.3.1. Someone was in 7.3. Okay, now it has scaled down everything under a particular range, minus 1 point, minus 2 point, minus 0 point, minus 2.90. Okay, just see the difference. Now means their difference is now very low, so that every points are in now a range. Okay, now in a particular range. Okay, they are all near, so that our classifier can access everything. Okay, they are not far away, they are all near. Okay, their difference is now very low. Let me just show you like this. 3 and then just see. Just first see 5.2.3. And just see, this is the first one, this is the second one, this is the third one. Okay, just see the difference. It was in 6.7, 3.3, 5.7, 2.2, and it scaled down in just 0 and 1. Okay, that's what standard scaler does, and that's why we need to do in KNN types of thing. In decision tree, why don't we need it? Because we don't analyze the because we don't use the distance thing to predict on decision tree. We just analyze the patterns and we make the decisions. That's all. Okay, so now we gonna fit X train, and let me show you what happens to X test also. X test is also converted, because we converted it here. X train, std, and with X. Sorry, here we need to of course apply Y train. Dot fit. Training is completed, and now to predict on this converted data, the X data have to be converted also. That's why we converted it now, because otherwise it will give wrong answers. Because simple, as our brain, our classifier trained it in this normal distributed data, so to predict whatever data you want to predict, okay, whatever input you want to give, you need to scale down also. You need to scale that thing also. Okay, you need to scale those features also. So here we have already scaled down our X test data, na? So here we need to to predict it. We need to give predict equals to KNN dot predict on X test standard. In decision tree, we give only where it is. We gave only X test. Okay, but as we have trained it on scale data, so we need to predict on scale data only. Okay, so as we have already scaled down the X test from here, so yeah, and then just we need to find the accuracy. Let me write the accuracy, and let me write the predict KNN, because it was the predict DT, I think, above. Accuracy is equals to accuracy score on Y test, again Y test, and predict KNN. Alright. Yep, and let me know the accuracy. Let me KNN. Okay. Alright, KNN 0.97%, and here I need to do 100. 97% accuracy we have now. Now let's predict on custom data. Okay, like custom data means of course in again 1 1 1 1, nah? So let me just copy paste those. I don't want to create. Oh no. Just give me 1 minute, guys. Yep, here we go. There we go. X, KNN goes. First, I will show you what happens if you don't predict on scaled data. Okay, and it will always give you wrong answer. Always. Okay, always. DT not. It's KNN dot predict. Okay, what we did, we created a to give input. We created a variable called xnn, and now we are predicting it. We created another variable called xnn prediction on custom data to predict on that custom data. There we go. X, that's in name because I just copy pasted in prediction. You know why I give prediction. xnn. I think everything is fine now. Oh. Just see the difference. In it is showing Iris virginica. Okay, and in decision tree it showed Iris setosa, because as I said, if you give the classifier to predict on non-scaled data, okay, this data is not scaled now. Its value is 1111. Okay, even if you give 5, 3, 4 or whatever you want to give, 3.5 or whatever I'm just giving it. Okay, just see, it will always give you the last answer, you can say, because it will always give you Iris virginica, because for strange reason, whatever, but you have not scaled down this data, this custom data now. So you need to scale down it so that it can give you the right answer. Because again I am saying, you have trained it on this data, okay, this normal distributed data, so you need to scale down your custom data also, because now difference is very large. Okay, so let me just make it fun. Let me insert cell below one more cell I want. No, alright, I'll manage that. Alright, now as it is, just see right now our xknn in oh sorry, let me just run it again, 1111. Okay, and now we need to scale down in how? Again, sc.transform, and what we need to transform xknn, and let me change the name std. Okay, so we are scaling down our xnn, that is 1111, and we are naming it xnn std. So we need to make the prediction on std. Now let's see. In decision tree, for this value, it was giving result as Iris setosa. And just see, let me give one more cell here. Okay, std. Let's see. This value has been converted to this value. Okay. Now let's see. Iris versicolor. Okay. Alright. For key is equals to 5, it is showing the result of Iris versicolor. Okay. Let me give another. Let me give 6, 3, 4.8, 1.8. This one. Okay. I of Iris virginica 6, 3, 4.1.8. Let's see. 6, 3, 1.8, and I think it was 4.8. Virginica. Okay, and one more. Let's see for setosa. And after this, I am going to show you how to know the best value of k. Okay, 5.1, 3.5 again. 5.1, 3.5, 1.4, 0.2, 0.2. Okay, and Iris setosa. Okay, now we got our answer, and that's how you need to do standard scalar. Okay, that's how you need to do normal distribution, standard normal distribution of your data. Okay, now see what is the best value of k. That's all. K range in a range, k range is equals to range 1 to, let's say, 25, so we need to give 26. That's how basic Python works. Score equals to 0 and not in. I don't think I will need this, but scores list is equals to this code I am writing now. This one I got it from of course this is a simple thing, but still I don't know. I was just lazy. Again, I was going through a website and I just clicked the photo. See, I'm honest. I'm going to explain you what I'm doing with it. Okay. Let me just write nearest neighbor and an neighbor equals to k. Here we have given the range of 1 to 25, so it will actually predict our model and test the accuracy on all those k values. That is from 1 to 25, it will first go for k equals to 1. Okay, and it will see the accuracy, and then it will go for k equals to 2, and then it will predict and it will predict the accuracy. Okay, like it will plot the accuracy. Then it will it will set the value to 3. It will then predict on that and it will see the accuracy again till 25. It's gonna do knn dot fit x, let's say x train std with y train, and now fitting is done, but y again prediction, what we give a name, whatever. Okay, alright, into knn dot, you can give any name now you want, knn dot prediction on x test standard, then only it will give right answer. Now scores k, it will, like I will tell you, matrix dot accuracy. I need to import accuracy score of y test. Hey, we have already imported accuracy score. No? Sorry. Alright. Y test. Y test and this prediction. Just give me 1 minute, guys. Yes, we have already done it. Alright. In 200, I think so. But we are not gonna do this because we need to plot it on a graph. So in 200, I don't think it's gonna work. It's gonna plot. I don't know. I'm gonna show you what I'm doing. Just give me 1 minute. I'm gonna explain you accuracy score. Oof. Okay, now what it is actually doing is, here till here I just explained. Now it will take every value of k, it's gonna predict, it's gonna train on it, it's gonna predict on x data set, and it's gonna find the accuracy. Okay, it's gonna store it here, and this accuracy list, okay, it's gonna append those scores. Means if for k equals to 1, if accuracy is 80%, then 80, then append means it will just append the list 80. For k equals to 2, if accuracy is 79, so 80 comma 79. Then for 3, if accuracy is 93, so 80 comma 79 comma 93. So that's how it's gonna go. Let me run this, and I got a problem. Object is not attribute prediction. Where? Damn it. Here I did something wrong. I can say that. Yes. Now let's plot them. plt.plot k range. We gonna plot k range and scores list. It means x gonna be the range of k and y gonna be the scores list. And okay, so I think where I did wrong is how can I do this wrong? Yeah, just copy this and there we go. There I go. And before going further, let me check this course list manually. Just say this 93, 95% and 90. Yes, scores are varying now. Yes. So see this from I think 2 and from 2, like from 3, even from 3 or from 4, from 3 accuracy is above 97% till 16 or 17k. Okay, like for the value of k, the accuracy gonna be like from 3 above 97% to till 16. Okay, then it is going down, up and up for like 18. I don't know if we plot it with plotly, then it's gonna show. Okay, let's try here. Okay, that's how you can actually find the best value of k. So here in our case, from 3 to 16 will be the best value of k because accuracy is gonna be above 97%. So let's try on this. Actually, try on this. Where it is? Yeah. What we did is we tried 5 now. From 3 to, let's try 9. Yeah, 97. But after 16, now let's try 22. 95. Yes, the accuracy is getting down and it is very down for 25. No, okay, it is very down for 25, like 91% almost. So let's try that for 25. Yes, 91%. So our model will give the better accuracy rate from when the value will be from 3 to 16. So anything right, 7 is gonna be above 97%. Okay, so that's how you find the best value of k, and that was all about k nearest neighbors. Let's move forward for our last algorithm, that is of unsupervised learning. K means here k is very different. Okay, just don't get confused. Now whatever you learned above now, that was supervised learning, that was whole different. Here it is whole different concept gonna apply. Here k means very different. Okay, just don't get confused with that k. This k is different. Okay, let's understand what is k means. Okay, let's understand what is clustering first. I've already explained you like in the beginning, but let's understand what is clustering here. It's a simple process of separating data. Like, of course, this comes under unsupervised learning. That means we don't have any labels to classify
the data like in KNN and decision tree, we had labels like iris setosa, iris virginica, iris versicolor. But in unsupervised learning, we are not going to use that Y. Okay, you know X, you know the features. Okay, and what we used to do, we used to just train our model with train X and with like if I say train X, what we used to do, X train, sorry, X train. Okay, we used to train our model using X train data with Y train data. Okay, here we had our labels, but in unsupervised learning we don't have labels. That's the whole point of unsupervised learning. Okay, so we are not going to use Y train or Y test. Okay, we are just going to use full X, not X train, not X test, but we are actually going to use full X test. That means no 70% dividing and no nothing else. We actually gonna use 150 of its features. Okay, so we gonna use whole X as an input to our training model, and first I'm just gonna and then KNN dot fit. Okay, like just see here what we used to do. We used to just see here what we used to do. We used to do our model training by giving X train comma Y train. Okay, but now we just gonna give whole X to train because we are assuming that we don't have any labels. Okay, and let's where is that graph which I can just actually show you. Okay, just see this. Okay, we have our data. Okay, unclustered, and like it is all messy here, and it has no labels. We can just actually see the colors. Like, of course, we are not seeing from computer's vision, like from computer side of view. We are just saying that it is red, it is green, it is blue, but our model it just doesn't know that it is blue, red, or green. So what we're gonna do, we just gonna give it to we just gonna give this data to our model to train. Okay, and it's just gonna see. It just separated out some set of points from all the points. Okay, just see, set of red points is here, set of green points is here, and set of blue points is here. That means from unlabeled data, it has just trained according to their patterns. Okay, and what is their pattern? Colors. So the model gets trained according to their patterns, and it just clustered all the data into some amount of sets. Okay, like this is a group of red point, this is a group of green, and this is a group of yellow. Similarly, just see this. Okay, it's just gonna clustered according to their patterns. Okay, like yellow set of colors is here, red set of colors is here, and blue set of colors is here. Okay, yes, see, purple set of colors is here. Okay, this circle are in different group. Okay, so that's what clustering is all about. Okay, just cluster the unlabeled messy data and arrange them together according to their patterns. Okay, arrange them in k number of groups. Listen, here k is very different. In k means here k is very different from k of KNN. Okay, so like of course, because that was classification problem, that was supervised learning. This is unsupervised learning. Everything is different. Okay, everything. So it's just gonna divide the unclustered data in the k number of groups. Okay, so what is k means? K means is just the type of clustering we make the amount of groups, like how many groups do we want. Okay, how many groups do we want? I mean how many groups we want from our model to make for us like according to the patterns of the data. Okay, like just see here. So K means is just basically, I just told you how many groups of like data points we want from our model. Okay, like in iris solver problem, we have basically 3 groups, but of course the model doesn't know na. We are doing unsupervised learning, so we don't know how many labels are there. Earlier we had 0, 1, 2, 0 for Setosa, 1 for versicolor, 2 for Virginica. But here we are just using X and we don't know what is Y. Okay, like we just don't know what is the label of the data. So we will give like n cluster is equals to 3. That means K is equals to 3. It's up to us actually. It's up to us how many groups do we want by our model. Okay, so what I did is I just gave the input of 3 so that at the end we get like we get data we get data divided by just only 3. Okay, and I guess this is for Setosa, this is for versicolor, and this is for Virginica. If you said n cluster is equals to 4, 5, 6, then it will divide this data into more subdatas. Okay, so now let's run this. Okay,
let's start. As I said, now we are not going to use the Y, but still I want you to know like how does it looks like as we did for KNN and decision tree, no? Okay, we did for KNN and decision tree. So let's just see how does it look like before fitting into the clustering model. Okay, we are not going to use Y. Okay, Y is having no use, but as after doing above thing, like just assume right now we have labels and like Y now. So just let's see how does it looks before fitting into the clustering model. But again I am saying this Y has like no use because unsupervised learning is all about unlabeled data. Okay, but plt dot scatter, and let's go for like x-axis and y-axis. Scatter, we're gonna use petal length and petal width. So we want to look petal length and petal width. So petal length and petal width. And we want to use color map of Y. C is equals to color map Y size in 50. Color map Y means it's simple. Y means Y, what we have Y 0 0 we have Setosa 0, versicolor 1 and Virginica 2. So that means for like color map Y, okay, for 0 we will be having red, okay, for 1 we will be having green, and for blue for 2 we will be having 2. Okay, that's all. According to the Y, it will change the color. What I did wrong? Wait, but with iris. Oh, I'm so sorry, yeah. Iris. All right. All right. This is our this is how initially our data looks. Okay. In terms of petal and petal width, you can do it for sepal and sepal width also. But now let's assume we don't have any labels. Okay, we don't know that
we don't know that this label exists. Okay, this species of labels exist. We only have X. We don't have Y. Okay, we only have X. So we're gonna give our model to separate it out according to its pattern. Now it will separate it out into 3 groups. Okay, so that we will assume that the first group is Setosa, second is like, of course, because the pattern will be different, so the set will be different now, like this. Okay, so according to the pattern, it will separate it out the data into 3 different groups. Okay, it will just separate it out, this whole data, into 3 different groups. Okay, so we will get to know, okay, there are actually 3 flowers, or like, then like we will just assume that, okay, this is Setosa, this is versicolor, or this is virginica, or whatever. This is how recommendation system works actually. Beginners who are not able to understand, just be patient. Okay, now let's start from sklearn dot cluster import k-means. Beginners who are not able to understand, just after some like going through the theory, you will understand. Okay, just be patient. How many sets do we want to divide into? Like 3. Okay, and let's say data on a random state. Okay, initially it is in 2. Okay, right now km dot fit, we're just gonna fit X because we don't have Y. Okay, but above, again I'm saying that above we did for like we know the labels now, so we just wanted to see how does it look before clustering. But now just assume we don't have Y. Okay, it will create its own Y. Centers equals to km dot cluster centers. I'm gonna explain what I'm doing. Okay, let me just write it in like below cell. Okay, let's fit the model. What k means okay, this k is bigger and this k is bigger. Oh, I am doing this. And clusters and clusters. Now, as we have divided the data, so we just want to know like what is the centers. Okay, like this now, what is the center, first center, second center, third center, so that it's get divided according to that. This is our centers. Okay, now see, let's see what is the labels our cluster has given. Na? Same as like we had, but sometimes it has misclassified. Let's see, and if I talk about like my previous result, classification does happen, but for Setosa it gave 1, for versicolor it gave 0, and for virginica it gave 2. Alright, and we have now this. Misclassification does happen, so I'm going to use one more thing here. And jobs, I think this is just a parallelization thing. Let's see. Okay, we got our results, and let's see. 1 is for Setosa, 0 is for versicolor, and 2 is for virginica. Better than before because misclassification is not happening that much. Okay, you can search for what is and jobs in Google. It's nothing but just a parallelization thing. Okay, what is and job? Okay, you can just
and jobs in and random forest in Python, you can say, okay, or in clustering, whatever same is. You can just search for it, like what is parallelization and what does it do, okay. Okay, let's start. And we know what was our category now, so let's give the name according to that, okay. Category, let's I'm just giving the name. There you go. But iris versicolor should be here in case of this. Setosa. Now see, iris versicolor is now first, Setosa is second, and Virginica is third, okay. Let's see, and let's go further. And let's see how does it looks after fitting into the model, okay. Just this after fits into the model. Just need to do km.labels this, okay, after fitting in model. Okay, so that's how it is looking after clustering. You will not see much difference in like this and this, but just let's see side by side, okay, both of them. So I'm gonna just make subplots, new labels. Sorry guys, it's morning time and I'm recording right now, and you will see some sound of vehicles, so I'm sorry about that. It's just a last part. It's just a last part of our whole tutorial, so please be just manage, okay. Just subplots 1, 2, and figure size will be just like that, even in lockdown time. Alright, access 0. If you learn how to use Matplotlib, so you know what I'm doing. In the first, just let me just show you how does it gonna look. Fixed size is not defined. What? Oh, sorry. Fixed size first to this parameters. And what are we wrong now? Okay. Subplots illegal arguments. Why? 1, 2. It used to be. Like even there, no? Okay, subplots. Okay, in this plot, first we're gonna draw for actual data, and second one is gonna draw for after clustering. Okay, so let's just see. Access 0 equals to access 0 dot scatter. In the first this 0th graph, we want like what we want, petal length and petal width. Like we are going for petal length and petal width. Okay, not sepal width, but you can do it for like, so we want all the rows. And which column? Second, because in the second column we have petal length, and in the third column we have petal width. Okay, so we want all the columns and here, and we want only second row. We want all the rows and we want only second column. Okay, and 3 C equals to y, like it was the actual data. No, we know that it was actual data. Guest window, you know, rainbow. It's all a color thing. Okay, H color gonna be our ADGE. H color gonna be our K. K means black, I think.
s equals to size 150, and same I'm gonna do for first one. Just no, chat, so that let's even you can see the difference. I think we are set. See, let me put out the title, and if you want you can put out the x0 dot set title. Okay, for x level you can do x label and do rest of the thing. Let me show you how to put out the title, and for y level you can do y level. Okay, actual, oh sorry, actual, and the font size gonna be 18. Let's see. One actual, and after clustering you can see a predicted. Okay, this was our actual data and this was the predicted one. Okay, you can just do like just see, they are not much different, but still this is Satosa, I think, and this is like the number 1, because our model has given the first one as 1, and the second it will create its own label. Okay, because we have not given any label. Okay, like y to train, we just give x to find the patterns and just divide the data according to 3 sets. Okay, according to the patterns, divide this data into 3. Now let's just predict the last part. Okay, now let's predict on custom input. Let's just see where it is. Yeah, alright, we don't need to transform anything because of course we have just given raw data. Okay guys, if it gives 0, that means it is iris versicolor. Okay, not Satosa. If 1 it is giving, then it is iris Satosa. Let's start tip xk and what? Oh sorry, I just wanted to key means I did for 1 only here. Okay, let's give the name for x key mean, and let's see is Virginica. Oh, what is the problem? If you remember for decision tree we got iris Satosa for 1111. Let's see, otherwise we have did something wrong, I think. We did something wrong. Alright, damn idiot, I am damn idiot. Alright, how can I do this? KM. Alright, Satosa. Okay, this is good right now. And earlier data. Alright, iris Satosa, yes. And let's try for some more custom data. Input 634.8 1.8 for iris Virginica. Okay, how can I do this? 6.3 4.8 and 1.8 versicolor. Alright, some misclassification happened. Okay, and let's actually try for another 7.13, like for iris Virginica. 7.13 5.9. let's see, 7.13 5.9. 2.1. Yes. Okay. Alright. It's now giving some. Okay. It's giving some accuracy, but alright. Some misclassification does happen if you analyze this data. If you have analyzed this data, then you know. Alright. So our project is completed. We did all the things. Okay, first we imported the data, then we did visualization, and then we did prediction for decision tree. We understood decision tree. Then we did for k and n. Okay, we get to know what is the best value of k. Then we did it using clustering. So if you like this tutorial, please like it, subscribe to my channel, hit the bell icon, and because I'm gonna post many kind of projects like this. Okay, so guys, see you with the next video. Okay, bye bye.